So welcome students. So in this question you're given that n factorial is 1 into 2 into 3 into so on up to n. So n factorial is the multiplication of first n natural numbers. N factorial is the product of first n natural numbers. And it's given that you have some n factorial such that this n factorial has 4 zeros at the end. And n plus 1 factorial, the next number factorial, has 6 zeros at the end. If that is so, what is n fact? What is the value of n? So first try to understand what n factorial is. So according to the given definition, n factorial, example 5 factorial is nothing but 1 into 2 into 3 into 4 into 5. Example 10 factorial is nothing but 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. So on, if you write different factorials, so you get different products. And you're given that n factorial has 4 zeros at the end. N factorial has 4 zeros at the end. So now if you multiply all these numbers, if you multiply these numbers, 5 into 4, 20, into 3 is 60, into 2 is 120. Similarly, 10 factorial, it's not very easy to multiply, but if you multiply, you get some number. So now if you want to analyze how many zeros you get at the end of some number factorial, so how do you analyze it? So if I want to find the number of zeros, at the end of some n factorial, so I need to analyze something. My method is something like this. So 120 is nothing but 12 into 10. So if there are 2 zeros at the end, it should be 12 into 100. So if this 5 factorial has a 10, if it has a 10 power 1, you have 1 zero at the end. If a number factorial has 10 square as a factor, you have 2 zeros at the end. If it has 1000 as a factor, it has 3 zeros at the end. So on. So if you have to have a 10, so 10 is made up of 2 and 5. So whenever you have a pair of 2 and 5 as factors, you get a 10 as a factor. So if you have 2 pairs of 2 and 5s, that means you have 2 10s, that means you have 100 as a factor, that means you have 2 zeros at the end. So if you have 3 pairs of 2 and 5s in the prime factorization, you have 1000 as a factor, you have 3 zeros at the end. So now if you want to find the number of zeros at the end, you have to see how many pairs of 2 and 5s are there. So example, if you want to analyze 10 factorial. So in 10 factorial, you can see that you have a 2 here, you have 2 2's here, you have a 2 here, you have 3 2's here, you have a 2 here. So you have 1 2, you have 2 2's, you have 1 2 again. In 8 you have 3 2's, in 10 you have 1 2. So total you have 5, 6, 7, 8 2's. You have 8 2's in 10 factorial. Similarly, if you want to count the number of 5's, so you have 1 5 here and you have a 5 in 10, because this 10 is 2 into 5. So effectively you have 8 2's and 2 5's. So how many pairs of 2 and 5 are there? So I want the pair of 2 and 5 to get a 10. So how many pairs are there? So you have 2 5's and you have 8 2's. So effectively you have 2 pairs of 5 and 2's. That is, if you club 5 and 2, because you have only 2 5's, you can get only 2 pairs. That means 10 factorial has 2 zeros at the end. So 10 factorial has 2 zeros at the end. Now it's given that my n factorial has 4 zeros at the end. So what should be the value of n? So you can analyze it very clearly. So you can see that whatever factorial you write, the number of 2's is not a deciding factor, because you have a lot of 2's in comparison with 5's. 5's are the deciding factors. So if you want 4 zeros at the end, you should get at least 4 5's. So if you take 20 factorial, if you see, 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11 into 12 into 13 into 14 into 15 into 16 into 17 into 18 into 19 into 20. So now if you take 2's, you have a lot of 2's. You have a 2 here, 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 here. So you have a lot of 2's. So 2's are not the deciding factors to get pairings. So let me count the number of 5's. So you have a 5 here, you have a 5 in 10, you have a 5 in 15, you have a 5 in 20. You have 4 5's. So 4 5's will pair with 4 2's to get 4 10's. So 20 factorial will have 4 zeros at the end. You have some number followed by 4 zeros. So before 20 factorial you won't get the 4th zero, because 20 factorial, if you want 4 zeros you need 4 5's. The 4th 5 is coming from 20. The 4th 5 is coming from 20. Next, if you had 21 factorial, also you have only 4 zeros, because in 21 factorial you have an extra 21. This does not contribute any 5's. So 21 factorial also has 4 zeros at the end. 22 factorial also has 4 zeros at the end, because unless you get an extra 5, you won't get an extra 0. So in 23 factorial also you get 4 zeros, because you don't have an extra 5. 24 factorial also you get 4 zeros. But 25 factorial, let us look at 25 factorial. If you have 25 factorial, so in 25 you have 2 more 5's. 25 is made up of 2 5's, 5 into 5. So you have 6 5's now. So in 25 factorial suddenly you get 6 zeros. Can you see this? So in 25 factorial, because you get an extra 25 here, 25 is made up of 2 5's. So till 20 you have 4 5's, 25 you have 2 5's extra, so total 6 5's, so you get 6 zeros at the end. So can you relate it to the problem given? So n factorial has 4 zeros, the next number factorial has 6 zeros. So what should be the number? So the number has to be 24. Can you see this? So 24 factorial has 4 zeros, the next number has 6 zeros. So n has to be equal to 24. Thank you.